Hello everybody. Today I would like to talk about one of the post hoc test or the multiple comparison test, which is the Dunnett test. Dunnett test is applicable for both equal sample sizes and unequal sample sizes. The Dunnett test, one of the important feature for the Dunnett test, that it is the best multiple comparison test when we want to compare the results of the different groups in regard with the what's called the control group. So we have control group and we have other group. We need to compare the other groups to the control one. Also, one of the benefit of adopting the Dunnett test is that this test can control in a good way the type 1 error without any increase as the number of the comparison increases. Let's see what we have here, this question, in order to understand all related to the Dunnett test. We have a foreman, and this foreman wants to check two new types of machine operating on new technologies regarding the productivity rate. So we have two new machine, a new machine number 1 and a new machine number 2. We need to check for the productivity rate for both of these two new machines. The records for the productivity, and this is the unit of the productivity, how many units the machine produce in 1 hour, have been recorded in below table, along with available standard machine. So we have available machine, we call it standard machine, and we are investigating the two new machine in order to replace the standard one. So the records were taken on 4 randomly occasion. So here the table below, we have the productivity records for the 3 machines, the standard one, which is available in the machine, in the company, and this is the new machine number 1, and this is the new machine number 2. Regarding to the records, these are the records for the standard machine in 1 occasion. Number of products produced in 1 hour was 22, while in other occasion it was 23, on other or third occasions 25, and in 4th occasion it was 21. Regarding the new machine 1 and the new machine 2, the records already inside the table. Here in the table below to the right, we have the different statistics regarding the 3 machines. We have 4 observations for each machine, and we have the average here for the productivity of each machine, and we have here the variance for the productivity for each of the machine. As we see here in the one-way ANOVA table, we see that the value or the F statistic value or the calculated F value is greater than the critical one, which is 4.26, sorry. So we conclude that there is a significant difference between the mean of the productivity for the 3 machines. So let's start solving this question. First, let's write the null and the alternative hypothesis. First, we have a null and alternative hypothesis for standard machine versus the new machine 1. We have the null hypothesis, which states that the productivity of the standard machine is the same as the productivity of the new machine number 1. Regarding the alternative hypothesis, the productivity of the standard machine is not the same or different from the productivity of the new machine number 1. So we need to test these hypotheses. Regarding the second hypothesis, we need to compare the productivity of the standard machine and the new machine number 2. So we have the null hypothesis, which states that the productivity of the standard machine is the same as the productivity of the new machine number 2. And the alternative one is that the productivity for the standard machine is not the same or different from the productivity of the new machine 2. So these are the null and the alternative hypothesis we need to test. First of all, let's calculate the standard or the absolute difference in the means regarding the productivity, first for the standard machine and the machine number 1. So the absolute mean difference is the absolute of the x bar c minus x bar 1. X bar c is the C here represent the control group. And regarding the control group, we have the standard one. So the standard machine, the productivity of the standard machine is the control group. So this is the control group. The mean for the control machine is 22.75. It's already inside the table above. And regarding the productivity of the machine number 1, it is 27. So the result will be the absolute value of negative 4.25, which is positive 4.25. So 4.25 represents the absolute difference between the productivity of the standard machine and the productivity of the new machine number 1. Regarding the standard machine and the new machine 2, the same technique or the same way, we calculate the absolute value of the difference in the productivity regarding the control machine and the machine number 2. So this is the mean of the productivity of the control machine or the standard machine, which is 22.75, and 28 is the mean of the productivity for machine number 2, and it's already inside the table above. So the result will be the absolute value of negative 5.25, which is 5.25. So we have two absolutes for the mean differences. Now, after the calculation of the absolute mean difference, we calculate for the Dunnett critical value. So what's the criteria in order to accept the null hypothesis or to reject? Is that if this value, the 4.25 and the 5.25, or at least one of them, for example 4.25, if the calculated value for the Dunnett test is less than 4.25, we say that there is a significant difference between the productivity for the control machine and the machine number 1. While if the absolute difference here is less than the calculated value for the Dunnett test, we say that there is no significant difference between the two means, which means that the productivity for the control machine is the same as the productivity for the new machine number 1. Same for the second value, which is 5.25, which is the absolute difference between the standard machine and the new machine number 2. So this is the criteria for accepting or rejection the null hypothesis. Now let's see how to calculate the value for the Donet test. This is the formula for the Donet test, Donet critical value. First, we should determine the value of T for Donet multiplied by 2 times mean square within, or mean square for the error. Mean square within is 3.19. It's already in the one-way ANOVA table, which is 3.19. And regarding to small n here represent number of observation in one group only, which is 4. So how to determine the value for the T for Donet? We should know 3 things. First, we should know the significant level. Then we should know small k, which is number of group, and we should know the total observation, which is capital N. So in order to determine T, we need to know all of these. So alpha is the significant level, and in our question it is 0.05. K represent the number of groups. We have 3 groups, 1 for the standard machine and 2 for the new machines. Capital N represent the total observation. We have 4 observation for each group, so the total is 4 times 3, which is 12. N minus K represent the degree of freedom for the error, which is 12 minus 3, which is 9. We can see that the degree of freedom for the error, it's already recorded inside the one-way ANOVA table. It's 9. And regarding the MSW, it's the mean square within, or the mean square for the error. And again, this is recorded inside the one-way ANOVA table, which is 3.19. And regarding small n, it is the observation number for one group, which is 4. Now the process is to determine the value for the T Donet. So we can return back to one of the Donet's table, critical value. First of all, regarding the row here, the row represent the K minus 1. K represent the total groups. We have 3 groups, minus 1, which means excluding the control. So we have 3 minus 1, we have 2. Regarding the column here, this column represents the degree of freedom for the error, which is already we have 9. So the intersection between the K minus 1 and the degree of freedom is 2.61. So the value for T for Donet test which is equal to T for alpha and K minus 1 and capital N minus K, which is T at significant level 0.05 and K minus 1, which is 2, and degree of freedom for the error, which is 9, and the value of this T for the net test is 2.61. So now simply we can substitute all these values in the Donet formula. This is the Donet formula. T Donet, it's already calculated. So the value of the T for Donet test is 2.61. So we can substitute. This is the value of T for Donet. This 2 is constant. This is the mean square within. It is inside the one-way ANOVA table in the above. And this is small n, which is 4. We proceed. We see that the Donet's critical value, or the calculated value for Donet test, is 3.29. Now simply we need to compare this value 3.29 with the absolute differences we have got. So in this slide, all the conclusions are here in the below table. This is the comparison between the standard machine and the new one. The absolute difference between the two means is 4.25, while the value for the calculated Donet critical value is 3.29, and the absolute difference is greater than the calculated Donet. So we conclude that we have a significant difference between the productivity of the standard machine and the productivity of the new machine one, which means that the two productivities are not the same. In this case, we reject the null hypothesis and accept the alternative one. So the mean for the standard machine is not the same as the mean for the new machine one. Which one is greater? We check inside this table. Regarding the average for the standard machine, it is 22.75, while for machine or new machine number 1, it is 27. So we conclude that the average of the productivity for the new machine 1 is greater than the average of the productivity for the standard machine. Regarding the second comparison or second pair between the standard and the new machine number 2, the absolute difference in the two means is 5.25. Again, it is greater than the calculated value for the Donet, which is 3.29. Again, we have a significant difference between the mean for the standard machine and the new machine 2, which means again we reject the null hypothesis and accept the alternative one. So the two means are not the same. Which one is the higher? Again, inside the table we have the productivity for the new machine number 2, it's 28. So 28 is greater than 22.75. So the conclusion here is that the mean for the productivity of the new machine 2 is greater than the mean for the productivity of the standard machine. Notice that in this type of multiple comparison test, which is Donet test, we don't compare between a standard machine between the new machine number 1 and the new machine number 2. Our purpose for adopting this test is to compare the productivity of the two new machines in regard with the standard one or the control group, which is the standard machine. So what's the final decision? Because both comparisons are significant, the administration can return back to some other criteria. For example, they can check for the price for the machines or the new machines. They can check for the availability of the spare parts. They can check for the cost of the spare parts, etc. That's all. Thank you for your watching. Kindly, if you have any comments, please write it down. Thank you.